Welcome everyone. In this video I am going to talk about MCQs or multiple choice questions related to the Fourier series topic. I already have uploaded different videos related to this topic, this course in which I have discussed multiple choice questions separately, and I also have uploaded all the content in this course already, which I have put in different playlists. So in case if you are new to the channel, take a look of the channel, subscribe it, because this will be useful for you in the coming semester as well, because the courses of mathematics that are going to be taught have already been uploaded on this channel. So let's start. I will not be discussing about the details. I will directly be solving the question. In case if you want to know the detail of the Fourier series topic, you should first watch the videos in detail of Fourier series, and that video are available in the Fourier series playlist. So which of the following is an even function of t? So a function is said to be an even function if f of minus t is equal to f of t. So clearly out of all the options, this option will be satisfying this condition. So the correct option is A. Second, given the function f of x is equal to this minus x when x lies between minus pi to 0 and x when x lies between 0 to pi, the value of the Fourier coefficient Bn can be computed as, and this is also a memory based question. You can clearly see that this function f of x is an even function, because if you try to draw its graph from minus pi to 0 and then 0 to pi, so minus pi to 0, the function is minus x, so the graph will look like this, and from 0 to pi the function is x, so the graph will look like this. So this is the graph of an even function because it is symmetrical about y-axis. I hope you remember this concept, that a graph is an even graph if it is symmetrical about y-axis. If the function, means interchangeably I have used the term, if the function is an even function, then its graph will have symmetry about y-axis. Okay, so this graph is making it clear that this function is an even function. Now what is the next thing? The next thing is that a function is even and if the interval is of type minus c to c, then the Fourier coefficient Bn becomes 0. So the correct answer is C. How it becomes 0? For that you have to watch the detailed video, because otherwise it will become a long one if I explain everything. I'm just expecting that you already have watched or you already have the understanding of the basic concepts of Fourier series. So this video is related to problem solving, so I'm not going into the details. Now this is also a very good question. In the Fourier series of a function f of x is equal to sin x in the interval 0 to 2 pi, the value of Fourier coefficient Bn is. Now you all know that how do you write the Fourier series expansion of a function f of x in the interval of length 2 pi. Here the interval is of length 2 pi, so it is written as a naught by 2 plus summation n varies from 1 to infinity an cos nx plus summation n varies from 1 to infinity bn sin nx. Okay, so if you just write it for your convenience in expanded form, it will be a naught by 2 and it will be a1 cos x plus a2 cos 2x plus a3 cos 3x and so on. And this will be what? This will be b1 sin x plus b2 sin 2x plus b3 sin 3x and so on. And we have to write the Fourier series expansion of the function f of x is equal to sin x, right? So if you look at this left hand side and if you look at the right hand side, you can clearly see, if you compare the coefficient, that b1 here is equal to 1 and b2 b3 and all other Fourier coefficient, means all other Fourier coefficient like bn will be equal to 0 when n is not equal to 1, means b2 b3 b4 b5 everything will be 0. So the correct option will be C. I think this must have been a new problem for you, and I hope you have understood it. Next question, question number 4. So the Fourier series expansion of a periodic function fx defined in the interval minus 1 to 1. If f of x is an even function, then we know that if f of x is an even function, then the Fourier coefficient Bn is equal to 0. This is a very important concept, and this concept is used to solve many questions. So remember this. Now this is not a question, but this is a very important slide, and I want you to remember these results because sometimes they directly ask it. Sometimes they give you a series and then they ask you what is the value of this, and if you remember this, it is very easy for you just directly to answer the question. So you can see that 1 by 1 square, 1 by 2 square, and so on up to this is equal to pi square by 6. This value 1 by 1 square minus 1 by 2 square, this is equal to pi square by 12. This is equal to pi square by 8. This is equal to pi to the power 4 by 90. In case if you have watched the playlist, I have proved all of these 4 results in detail in one of my videos in Fourier Series playlist. Okay. So the question that has been asked and is like this, like Fourier series of the periodic function with period 2 pi is given by this. So this is the Fourier series of the function f of x is equal to pi by 4 and summation and so on and so on. Now they are asking the value of 1 by 1 plus 1 by 3 square plus 1 by 5 square. So if you just remember this result, that what is this expression? This expression is basically 1 by 1 square plus 1 by 3 square plus 1 by 5 square. Yes or no? Because 1 can also be seen as 1 by 1 square. So we already know that answer is C, that is pi square by 8. But suppose sometimes it may happen that you may not remember, you may forget. So in that case you can do the substitution also. So if I have this expression and from this expression I want to get the value of this, so how can I get the value of this? Basically I can see that I want to get the n square term, like we have this n square term over here. So in this expression if I put x is equal to 0, so what I will get? I will get x is equal to 0 will give me cos 0, all these cos zeros will become 1. Okay, and all these, actually I hope you can see, this is minus 1 by n cos n pi sin nx. So sin 0, all these terms will become 0. So only this term will be left with us. So what will happen if I put this value? So I will get f of 0 is equal to pi by 4 and plus summation. So if I put 0 here, this cos 0 into n, cos 0 will all become 1. So I will get this summation 1 by pi n square and cos n pi minus 1. So we remember this result that cos n pi is equal to minus 1 to the power n. So if I take n is equal to even, then I will get 1, and if I take n is odd, I will get minus 1. So all those even terms will become 0, only odd terms will be left. So this will be like what? This will be like pi by 4 and plus 1 by pi will be constant, can be taken out of summation. All the even terms will become 0, so I will get 1 by 1 square if I take 3, and for all the what you call odd term, you will be like getting this value as minus 1. So you will get minus for n is equal to 1, I will get 1 by 1 square and then minus 1 by 1 square. That is what I was suggesting, because I will be getting this value will be minus 1. So minus 1 is minus 2. So rather I will get minus 2 by 1 square, right? And if I take n is equal to 3, then I will get minus 3, not 3, minus 2 by 3 square. I hope you got it. I repeat, cos n pi is equal to minus 1. Cos n pi is equal to minus 1 when n is odd. So this value will become actually minus 2 for all n odd value. Only thing that I will change is the denominator here, that is n square. So the next value will be minus 2 by 5 square and so on. So this is the expression I am getting, and this is the value of f of 0. Now the question is, how do you calculate the value of f of 0? So to calculate the value of f of 0, because the function is not continuous at 0, I hope you remember a result that if function is not continuous at 0, we calculate the function value at 0 as 0 minus 0 plus f of 0 plus 0. Yes or no? This is related to the discontinuity concept. So 0 minus 0 means in the left of 0. So the function value in the left of 0 is 0, and the function value in the right of 0 is x. So if you are just close to 0 in the right of 0, that will also be equal to 0. So this value is basically 0. So the f0 value is equal to 0. So if you simplify, you will get pi by 4 minus pi by 4 here in the left hand side, and here you can take minus 2 common, and if you multiply it here in the left, so you will get pi by minus 2, and in the right hand side you will get the desired expression 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. So this is nothing but pi into pi, pi square by 8. So the correct option is this. I just told you earlier also that in case if you feel like do not remember the result, then you have to spend all this time. Otherwise it is important to remember this result. You can answer it without thinking anything. You know that this value is nothing but pi square by 8. Okay, so this was the question number 5. Now this is a memory based question, that which of the following condition is necessary for Fourier series expansion of fx in the interval c to c plus 2l. So f of x would be continuous in c plus c plus c comma c plus 2l. So this is not a necessary condition, because we just have seen in this example that function is not continuous. Still we can talk about its Fourier series. Function should be periodic, so this is one of the requirements. So this is the correct option. This option and this option is also not correct. I hope you can answer this question if you remember the Dirichlet's condition for the Fourier series expansion. So if you remember the Dirichlet's condition, you can answer this question without thinking much. Okay. Now this is also a computation based question. So how to solve this? This is question number 7th. Okay. So to solve this, we have to calculate a naught. So what is the formula for a naught? Formula for a naught is 1 by c alpha to alpha plus 2c f of x dx. This is the general result. Here the interval is minus 1 to 1. Interval is minus 1 to 1. So the length of the interval, that is 2c, is equal to 1 minus minus 1, that is equal to 2. So this gives you c is equal to 1. So how will you calculate a naught? A naught will be 1 by c, that is 1 by 1. But the function is written in two parts, minus 1 to 0. So I integrate it from minus 1 to 0, and in this case the function value is 1, so I write to 1 dt, and then we have to integrate it from 0 to 1, and the function value is minus 2, so I write minus 2 dt, right? So 1 by 1 will be 1, integration of 1 is t, so limit minus 1 to 0, and here I will get minus, and this will give me 2t, limit is 0 to 1. Okay, so if I put the limit here for this 0 upper limit minus minus 1, so that will become 0 plus 1, and here we have minus 2 upper limit 1, lower limit is 0. So what I will get? I will get 1 minus 2, that is equal to minus 1. So the correct option is C. I am writing all these details just for you to understand, otherwise it could have been done directly. Okay. Now this is question number 8. Okay, let me write the question number also. So this is the question number 8, and this is also a good question, that f of x is this, then compute the Fourier series Fourier coefficient a naught. Can you see that this is an even function? How many of you can see that this is an even function? Let me know through the comment section. But in case if you are in doubt, I can draw the graph also, because why I have highlighted that this is an even function, because suppose I ask you that what is the Fourier coefficient Bn for this function, you can directly answer that it is equal to 0. If you look at this, the Fourier series has to be written in the interval minus pi to pi, right? So at 0 the function value is 1, so this is how it will be, and at minus pi the function value is 1 minus pi. So 1 minus pi will be something like 1 minus pi is 1 minus 3.14, approximate I am writing, so somewhere around here. So I will get a point here. At pi it will be again 1 minus pi, so I will get a point somewhere around here. So the graph of this function will look like this. Okay, this graph will look like this. It will be symmetrical. I have drawn it, but it does not look like symmetrical. Can I redraw? Or I hope you understand this is symmetrical. Okay, so if this is an even function, so how do you calculate a naught? A naught you can directly write the formula 2 by c, limit is 0 to c, and f of x dx, because the function is an even function. So, and what is the length of the interval here? The interval is minus pi to pi. Total length is interval is minus pi to pi. So the length of the interval is 2 pi, right? The length 2c is equal to 2 pi. So c is equal to pi. So I can write 2 by pi, right? And limit is 0 to c, so 0 to pi. And in that case, it will be like how much? It will be 1 minus x. So I can write 1 minus x dx. So if I evaluate it, I will get 2 by pi. Integration of 1 is x, and integration of x is x square by 2. Limit is 0 to pi. So if I put the values, the limit value, I will get pi minus pi square by 2 upper limit. For lower limit, it will become 0. So if you multiply pi and 2 by pi, it will be 2, and minus 2 to cancel, right? So 2 by pi, so I will get 2 minus pi. Do we have that option? Yes, the option D. Why I have written this? Just watch the video, Fourier series for even and odd function. Very, very important video. Don't miss it. Lot of questions will be there. Fourier series is a topic, and there are only 2-3 videos which I have uploaded. Don't miss those videos. Watch them with all your attention. Okay. Now this is the next question, question number 9. Let me write this question number 9. So what is the value of cos 2n pi? So the correct answer here is 1, but let me also talk about other possibilities which may be there. So first of all, you need to remember this result. Cos n pi is equal to minus 1 to the power n. They may ask this. If they ask you what is sin n pi, so you should remember this is equal to 0. If they ask you what is cos 2n plus 1 into pi by 2, this is equal to 0. If they ask what is sine 2n plus 1 into pi by 2, this is equal to minus 1. So different multiple choice question can be asked. Cos 2n pi, actually if I remember this, cos n pi is minus 1 to the power n. So cos 2n pi is minus 1 to the power 2n. So 2n will always be even, so it will be equal to 1. So that is how it should be solved. Now this is the question number 10. Okay, f of x is equal to this. Compute the Fourier coefficient a0. Now here again you see the interval is of type minus c to c, because it is minus pi to pi. So length of the interval 2c is 2 pi. So this gives us c is equal to pi, and we have to calculate a0. So a0 can be directly written 2 by c, so that is 2 by pi. Then limit of integration 0 to c, so 0 to pi. I hope you understand why I am not writing minus pi to pi, because I already have taken 2 by pi. And why I have done so? Because this is an even function. Why it is an even function? Because if I write f of minus x, I will get minus x sine minus x. Okay, and minus x and sine minus x is what? It is minus of sine x. So if you multiply minus x and minus of sine x, I will get plus x sine x, means I will get the same function, that is equal to f of x, right? So I can write just function f x sine x, and I can integrate it. So how do you integrate? You integrate it using integration by parts. So the integration by parts is that first function x integration of let me write it. Some of you may not follow, so I am writing integration of sine x dx, then minus integration of sine x dx into differentiation d by dx of x, and then we integrate the entire thing. The limit of integration is 0 to pi. Okay, so it is now I will write it directly. So integration of sine x will give me minus cos x, so I will get minus x cos x, and since it will give me minus cos x, so this minus will become plus, and d by dx of x will become 1. So I will just get plus integration of cos x, which is nothing but sine x. Limit of integration is 0 to pi. If I put upper limit pi and lower limit 0 in this term will become 0. So no need to do anything. So I just have to put the limits in the first term. So I write 2 by pi, and if I put upper limit here, I will get minus pi cos pi, and if I put 0 here, 0 x0, so it will become 0. So this will be what I will be getting. So this pi and this pi will be cancelled. I will get 2 with a minus sign, and cos pi is nothing but minus 1, so that is equal to 2. So the correct answer here is D. So this was question number 10. Now let us talk about this question number 11. The half range sine series of f of x is equal to 1 in the interval 0 to pi is. So first of all, when we talk about this is the half range. Half range is 0 to pi. So what we usually do when we have to write the sine series of a function, we extend the function in the interval minus c to c, means in the interval minus pi to pi, so that the function becomes an odd function. And in that case, how you write the Fourier sine series? The Fourier sine series is written as summation n varies from 1 to infinity bn sine nx dx. It can be sine n pi x by c, but since c is here pi, so n pi x by pi will actually be sine nx dx, right? And when I am writing n and x looks same, so that you need to be careful, right? Now we have just to calculate bn. So how to calculate bn? Can I calculate bn in this side? So bn is equal to and formula for bn, if I am not wrong, you should remember, is 2 by c. So here what is c? C is pi, so 2 by pi, then 0 to c, so 0 to pi, and then you write f of x. So f of x here is 1, and sine nx dx, sine n pi x by c or sine n pi x by pi, so that is sine nx dx. So this will give me what? This will give me 2 by pi integration from 0 to pi and sine nx dx. So integration of sine nx is what? Integration of sine nx is minus cos nx by n, and limit is 0 to pi. So I can take this minus 2 by n pi, I can take this n out and minus out. I will get cos n pi and minus cos 0. So cos n pi is actually what? It is minus 1 to the power n. So minus 1 to the power n, and cos 0 is 1. So again you can see that the coefficients, what do you call it? This coefficients for n is equal to even, right? For n is equal to even, it will become 0. Can I write like this? For n is equal to odd, what I will get? This will be like minus 1 and minus 1. So I will get minus 2 and this minus 2. So I will get 4 by n pi for n is equal to odd. And for n is equal to even, I will get what? This will become 1 minus 1, so I will get 0. So if you look at this expression here, and write the Fourier series, what I will get? I will get summation n varies from 1 to infinity. Bn is 4 by n pi, and actually I will consider n is equal to odd only, right? 4 by n pi and then sine nx. So if you take odd, you will get what? You will get 4 by pi out, and for n is 1 you will get sine x. For n is 3 you will get sine 3x by 3, and for n is 5 you will get sine 5x by 5, and so on. So the correct answer here will be B. See, I again repeat, in case if you have not watched the Fourier series video completely, you should watch it, because some of the things might not have made sense to you, that why I am writing 2 by pi, or why I am taking the c or something like that. The function this, so we know that sine nx cos nx, sine nx is an odd function and cos nx is an even function. This is odd, this is even. And what is the question number here? This was question number 11, this is question number 12. So product of an odd function and an even function is an odd function. So the correct answer of this question here is A. Product of two odd function is an even function. Product of two even function is also an even function. Okay. Next question, question number 13. And if I look at the time, I have around 25 minutes in 24 minutes in the video. So I think I am taking 2 minutes time to solve each of the question, and it is like not that much, because usually we get 3 minutes of time. So how to find the Fourier coefficient A naught? So A naught is given by, So here what is the length of the interval? Length is 0 to 2 and then 2 to 6. So the length interval is basically 0 to 6. So the length of the interval 2c is equal to 6. So c is equal to 3. And they're asking a naught. So what is the formula for a naught? A naught formula is 1 by c. So 1 by 3. And here I am writing it integration from 0 to 2 and then t square dt, and then integration from 2 to 6 and minus t plus sorry dt. It's a very cold weather here. So it is 1 by 3 and integration of t square will be tq by 3, limit is 0 to 2, and plus minus t square by 2 plus 6t, and the limit here is 2 to 6. So we have to substitute the limits here. 1 by 3 and 2q will be 8 and minus 0q, so I will be getting 8 by 3. And if I look at this term plus, let us look at 1 by 1. So the first term I will get minus 1 by 2, and t square means 6 square minus 2 square. 6 square is 36 and minus 2 square is 4, so 32, and plus 6 into 6 minus 2, that is 4. So how much I will get? I will get 1 by 3 and 8 by 3, and this is minus 16 and plus 24. Minus 16 plus 24. Write it to avoid any confusion. Just to continue here, I will write 1 by 3, 8 plus 8 by 3. So how much is that? 1 by 3, 8 into 3, 24 plus 8, 32 by 3. So I will get 32 by 9. Do we have the option? Yes, D option. I would suggest you one more thing, that sometimes what happens, we tick the wrong option. So it is better to keep the subtitle open also, or on also, that sometimes if there is some kind of correction, I can explain through subtitle as well, right? Because sometimes the options are so close that we mistakenly tick the wrong option. Anyway, now this is another question. So this was question number 13. This is question number 14. So the period of cos 2x. So we know that cos x is a periodic function with period 2 pi. We also know sin x is a periodic function with period 2 pi. Tan x is a periodic function with period pi. This was not needed in the question, but just in case if they ask some other question, you should be able to answer. If I have to find the period of cos 2x, so what is the idea? That look at the period of cos x, that is 2 pi, and divide it by the coefficient of x here. So I divide it by the coefficient of x, that is 2. So this 2 and 2 cancel, and I will get the period that is equal to pi. So the correct option is A. Suppose I ask you what is the period of cos x by 3. So what will be your approach? 2 pi. You have to divide it by the coefficient of x, that is 1 by 3. So what you will get? You will get 6 pi. Okay. So this is how you should be able to solve this question. So the correct option of question number 14 is A. Which of the following function is an odd function? So clearly this function is an even function. What is the definition of an odd function? F of minus t should be equal to minus of f of t. So this function is neither an odd nor an even function. This is also neither even nor odd. So the odd function will be this, because if you put this sine in place of t, if you put minus t, you will get sine 2 times minus t plus 3 into minus t, right? Sine minus 2t will be nothing but minus sine 2t and minus sine 3t. So this is nothing but basically minus f of t. So the correct option is C here. Okay. So this was question number 15. Now let us move to the question number 16. Which of the following condition must be satisfied for the existence of Fourier series of a function f of x? This is actually Dirichlet's condition, very important, and they may ask questions in different forms, so just you remember this. F of x is periodic, single valued and finite. This is the first condition. It should be true. F of x has a finite number of discontinuity in any one period. That is the also true. F of x has at most finite number of maxima and minima. So this is also true. So since all the three options are true, so what is the most appropriate option? The most appropriate option is all the above. So this condition is actually the Dirichlet's condition for the expansion of Fourier series. Okay, now the question number 17. The an in the Fourier series expansion of this function, that is 1 by 4 into pi minus x square. The interval is 0 to 2 pi. So for this you have to do the calculation, and it may take some time, so you need to have some patience, because this is not something that you can quickly answer. You have to evaluate. So an, what is the formula of an an? 1 by c. Here the length is 2 pi, so 2c is equal to 2 pi, so c is equal to pi. So 1 by pi, lower limit 0, upper limit 2 pi. This is not, I am not looking at this function as even or odd, because the interval is not of kind minus c to c. The interval is of type 0 to 2c, right? And then we have the function 1 by pi into pi minus x square whole square, and then to find an we write cos n pi x by c. I am writing it for your convenience, otherwise I could have written directly also. So I am writing n pi x by pi. So this pi and pi cancel, so basically I get cos nx dx, right? Now I have to evaluate this integral. So 1 by 4 is a constant, I can take it 1 by 4 pi. Now we have two functions, that is pi minus x square and cos nx dx. So how do you integrate? You take first function pi minus x square, integration of second function, that is cos nx dx, minus integration of second function, that is cos nx dx, into differentiation of first function, that is d by dx of pi minus x whole square dx. Limit of integration is 0 to 2 pi. Now I will get 1 by 4 pi. Pi minus x whole square. Integration of cos nx is sin nx by n, minus, this is n here, it will be sin nx by n, and d by dx of pi minus x square is 2 times pi minus x, and pi minus x again with respect to x will give me minus 1. Some of the students will make the mistake, they will not write minus 1, right? This is a common error. Limit 0 to 2 pi. Now the best part is that if I put the upper limit, that is 2 pi, in this term, I will get sine 2n pi, so this will become 0, and if I put the lower limit, sine 0 is also 0, so this expression actually will go to 0. So what I will get? I will get 1 by 4 pi here, right? I am simplifying, so be careful, and we have minus 2 by n from this and minus this, so I can take this also, so it will become plus, right? So I will get plus 2 by n, and I will have the integration from 0 to 2 pi, and now I will have pi minus x sine nx dx. Okay, now I guess there is no confusion till now. Some of you may use trick of integration, but I believe that using tricks sometimes gets leads to confusion, so I am writing the detail. Now I have to again use integration by parts. So I am writing here, I will get this 2 and this 2 cancel, so I will get how much? I will get 1 by 2n pi. Okay, and here I have the first function, that is pi minus x, and then integration of the second function. So integration of the second function will be like minus cos nx by n. Okay, I hope you know the integration by parts, which I have written in detail here. And then you have to take integration of second function. So what you will get? You will get plus, and if you integrate this cos nx by n, you will get sine nx by n square, right? And if you differentiate pi minus x, you will get minus 1. So basically you will get one extra minus 1 here, so I just remove this and I write a minus 1, so that we don't have to write it again. And then the limit of integration will be 0 to 2 pi. We don't have a space, so I am writing over here. So this will give me what? Again, if you look at the second term here, minus sine nx by n square, if I put upper limit 2 pi, it will be 0, lower limit sine 0 will also be 0. So this term will vanish, this term will vanish, only this term will be left. So what will be this term? Let me start from here. So I will get 1 by 2n pi. If I put the upper limit here, and I can take this minus also, if you for your convenience, okay, let's continue with this. So I write upper limit, so I write pi minus 2 pi here in place of x, and then I get minus cos 2n pi by n. I hope you got this. In place of x, I will put 2 pi, so I will get 2n pi by n. And then I have to put the lower limit, so minus. Lower limit is pi minus 0, and I will get minus cos 0, because if I put 0, it will be like minus cos 0. So what I will get? I will get 1 by 2n pi, and cos 2n pi is 1, cos 0 is also equal to 1. So here we get pi minus 2 pi, that is minus pi and minus. So I will get pi by n. And here I will get minus 1 and then minus pi. So minus minus plus again pi by n. So I will get 2 pi by n, and we have, so I will get what? I will get 1 by 2n pi into 2 pi by n. So this 2 and 2 cancel, this pi and pi cancel. What I will get is 1 by n square. So this is what the answer is. So this was a slightly engaging question. It has taken some more time, but I hope you will be able to answer this, because some of the questions were memory based. So you should not think that this question cannot be asked, because they balance the paper. Next question. So this was question number 17. This is question number 18. So the Fourier series expansion of the function f of x in the interval minus pi to pi contains, now this is an odd function, f of x is equal to x is an odd function, and when you write an odd function, Fourier series for an odd function, then a naught and a n becomes 0. For even function, bn becomes 0, and interval should be of minus c to c type, right? So if the interval is of minus pi to pi type, the a naught and a n becomes 0, right? So cos nx terms becomes 0, and constant term is not present, so only term, that kind of term is present is only sine terms. I hope you remember that Fourier series is written as out. It is written as a naught by 2 plus summation n varies from 1 to infinity a n cos nx, in case of the interval is minus pi to pi of length 2 pi, and n varies from 1 to infinity bn sin nx. Okay. So if it is an odd function, then a naught means this term will not be present, this term will not be present, only this term will be present. So only sine term will be present, right? This question could have been asked in a different way, that the Fourier series does not contain, and in that case the option will become the cosine terms. But here they are asking that which term is contained in the Fourier series, so that is the sine term. Okay, I hope it is clear. Question number 19. So this is also a very obvious kind of question. The function that is given is 1 minus cos x, and an interval that is given is minus pi to pi of length 2 pi. This kind, if we have this kind of interval, we should always think first that can we somehow reduce this function or make see this function as even or odd function. So of course this is an even function, because if you write x is equal to minus x, you will get what? You will get 1 minus cos of minus x. And you remember this result, that cos of minus x is nothing but cos of x. So in that case it is equal to 0, bn is equal to 0. Memory based question. Which of the following function is neither odd nor even function? So this is even function. I hope you can see. This is odd function and this is odd function. So this function is neither odd nor even, because here this term is odd, this term is even, but if you can't consider this function either as even or odd function. So this kind of questions are quite repetitive. Sometimes they are asking which of this is even, which of this is odd, which of this is neither even nor odd. I mean, you should remember this concept very clearly. Once they asked this also, so you just remember this, we are not going into the detail. The behavior of Fourier series near a point of discontinuity is known as Gibbs phenomenon. This question has been asked once, so that is why I have considered this Gibbs phenomenon. The Fourier coefficient Bn in the expansion of x square in the interval minus p to p. Again the interval is of type minus c to c. So whenever the interval is of type minus c to c, we look at the function that whether it is an even or odd function. So in this case it is an even function, so the Fourier coefficient Bn will be equal to 0. So I hope this was question number 19, this was question number 20, and this is question number 21. Okay, so for 21 the correct option is A. Okay, for okay, actually I was thinking about the question number. I have possibly made a mistake. It was 19, this is 20, this is 21, and this is 22, not 21, 22. You might be thinking that what is the need of being particular about question number. I will talk about that later, because that will help you to put the options in the comment section. I am going to give you some of the questions. Okay, so up to 22 done. Now move to the question number 23. So again another interesting question, that if f of x is equal to pi minus x by 2 and the interval is 0 to 2, then the value of Fourier coefficient Bn is equal to. So here also we have to kind of do the complete evaluation. So it is not some shortcut, we have to do the evaluation. So the length of the interval 2c is equal to 2. So this gives me c is equal to 1. And what is the formula for Bn? So the formula for Bn is general formula. You remember, I write general formula this time. I hope you remember, alpha to alpha plus 2c f of x sine n pi x by c dx. So I substitute all the required thing here. 1 by c, so c is 1, so 1 by 1. Alpha here is 0, alpha plus 2c is 2. F of x here is pi minus x by 2, and sine n pi x by c is 1, so sine n pi x by 1 dx. So now let us just do the simplification. 1 by 1 is 1, 1 by 2 can be taken out. In limit is 0 to 2, pi minus x, that is the first function, and here we have sine n pi x dx. So 1 by 2 pi minus x, first function, integration of sine n pi x, so it will be cos n pi x by n pi, minus again integration of cos n pi x by n pi. So should I write directly, or let me write directly. So it will be minus sine n pi x divided by n square pi square. I hope you got it. First function, integration of second function, that is the sine function. So I will get minus cos, not sorry, here it is minus cos n pi x by n pi, and then minus, so integration of minus will make it plus, so that will be plus, and then if I integrate cos n pi x by n pi, again I will get sine n pi x by n square pi square, because this n pi is already present, and derivative of this pi minus x will give me minus 1, so I write minus 1, and the limit of integration here is 0 to 2. I hope you are clear about what I have just done. In case if you have doubt, just write it yourself. First integration of second minus integration of second into differentiation of first, and so on. So we have this term and we have this term. Now if I look at the sine term first, and if I put x is equal to 2, I will get sine 2 n pi, so 0, and x is equal to 0, so sine 0 0. So this term actually will become 0. So I am not going to look at this, I have to focus on this only. So here we have 1 by 2, right, and cos n pi, so I can take minus 1 by n pi out, so I take minus 1 by 2 n pi, and now put the limit. So upper limit is 2, so I will write what? I will write pi minus 2 and cos 2 n pi, cos 2 n pi, and then minus the lower limit is 0, so I will write pi minus 0 and cos 0. This minus term and n pi I already have taken common. Cos 2 n pi is equal to 1, cos 0 is equal to 1. So what I will get? I will get minus 1 by 2 n pi, and here pi minus 2, and from here I will get minus pi. So this pi and minus pi is cancelled, and this minus becomes plus, and this 2 and this 2 cancels. So what I will get? I will get 1 by n pi. Yes or no? So the answer is 1 by n pi. We have answer 1 by n pi. Yeah, we have the answer A, that is 1 by n pi. Okay, gentlemen and ladies as well, if you are watching the video, I hope you are learning something. The value of the Fourier this is kind of poor question but has been asked, so that is why I have put it here. The value of the Fourier coefficient a5 in the half range sine series of cos x in this interval. If you are writing the sine series, means you will have only the Fourier coefficient bn. So all the Fourier coefficient an will not be present, because if you are writing, how do you write a sine series of a function? The sine series of a function is given by n from 1 to infinity and bn sine n pi x by c. So how can there be any an? There will be no an. So all the an will be equal to 0. So in particular a5 will also be equal to 0. Not a good question, but if they ask, you should be able to answer this. So I missed to write the question number. This was 22. Let me call this question number 23 and this is question number 24. Okay, question number now 25. So the value of b2, not bn, in the half range sine series of f of x is equal to x is. So how do you what is the half range sine series? I just wrote it earlier, but again I repeat it. The half range sine series is written as summation n varies from 1 to infinity bn sine n pi x by c, and you have to write half range sine series. So this is the half range, so you have to extend the interval from -2 to 2, right? And when you do that, you get the bn value. How do you evaluate the bn? You get the VL value 2 by c 0 to c f of x and then sine n pi x by c dx. This is all about sine series. In case if you have doubt, watch the video, the detailed video. So if I have to calculate b2, how I will calculate b2? First of all, I will write 2 by c. So what is c here? C here is 2. So 2 by 2, right? And then f of x. So f of x is equal to x, limit is 0 to 2, and then sine n pi x by 2, right? So I will write sine, and actually we are calculating b2. So I have to take n also equal to 2, right? So sine 2 pi x by 2. So let me write it for your understanding. 2 pi x by 2 dx. So this 2 and 2 cancel. So what I will get? This 2 and 2 also cancel. So I just have to integrate 0 to 2 x sine pi x dx. You remember the integration by parts formula? If you do not, I am writing the detail this time. X integration of sine pi x dx, limit is 0 to 2, minus integration 0 to 2 integration of sine pi x dx into d by dx of x, and then we integrate this entire thing. So I will get x integration of sine pi x will give me cos minus cos pi x by pi, limit is 0 to 2, and here I will get minus, and this will give me what? This will give me minus cos pi x by x. So this minus will become plus, and this dx by dx will become 1, and when cos pi x by pi will be integrated, it will give me sine pi x by pi square. For this the limit is 0 to 2. So if you put the upper limit 2 here, sine 2 pi 0, lower limit 0, sine 0 is 0. So this term will vanish, right? We just have to evaluate this term. So if I put 2 here in place of x, I will get minus 2 by pi cos 2 pi. Okay, and if I put 0 here, let me write it like this. So if I put 0 here, x is 0, so 0 into everything will become 0. So I will get just this thing. Cos 2 pi is equal to 1. So I will get the answer minus 2 by pi. So do we have the answer minus 2 by pi? Okay, no answer. Did I make some mistake? Oh no, sorry. See, this is actually the answer, minus 4 by 2 pi, and this is just kind of trying to confuse you. I mean, I got minus 2 by pi, but they have given the answer minus 4 by 2 pi. Actually this should be avoided by the paper setter if they are setting the questions. But if they ask, you can't say that it is a wrong question. You just have to be slightly more careful, because minus 4 by 2 pi will be the correct option. Okay. Now this was question number 25. Now let us take the question number 26. So the Fourier series for the function f of x is equal to e to the power minus x in the interval 0 to 2 pi contains. So this is the interval not of type minus c to c. It is 0 to 2 pi, and this is neither even nor odd function. So the Fourier series expansion will contain both sine and cosine terms. So this is also a very simple memory based question. So no need to think much about this. Now this was my question number 26. This is my question number 27. Now let this be the Fourier series representation of a function. I don't know what is the function in the interval minus 1 to 1. Then what is the value of a3? So this is how the Fourier series is written: a naught by 2 plus an cos n pi x by n pi x by c. Here the c actually is 1, so that is why it is n pi x only, and bn sine n pi x. So what is an? So an basically is 1 minus cos n pi by n square pi square, but they are asking a3, so I will get 1 by cos 3 pi and by 3 square, that is 9, and pi square. Cos 3 pi is minus 1, so 1 minus minus 1 is 1 plus 1 by 9 pi square. So 2 by 9 pi square. So this is an easy question, you should be able to answer. This is question number 28. We have to calculate a naught. So a naught is 1 by c. So what is c here? The length of the interval 2c is 2, so c is equal to basically 1. So 1 by 1 interval, limit is 0 to 2, and then f of x is cos hyperbolic x by 2 dx. See, basically if you remember the hyperbolic function, it can be directly written the integration of cos hyperbolic is sine hyperbolic, but some of the students may not be aware about those hyperbolic integration or differentiation terms. So I'm going to give it slightly longer but more kind of known kind of explanation. So I will write it 0 to 2. Cos hyperbolic x, I hope you remember, is defined as e to the power x plus e to the power minus x by 2. Okay, so here I can write it as e to the power x by 2 plus e to the power minus x by 2 dx. So 1 by 2 is a constant out. Integration of e to the power x by 2 is e to the power x by 2 by 1 by 2. So that is 2. And this will be minus 2 e to the power minus x by 2. Limit is 0 to 2. So this 2 can be taken out. This 2 will cancel both of these 2. If I put upper limit 2 here, I will get e. 2 by 2 is 1. Lower limit, if I put 2 by 2 minus 1, so I will get e to the power minus 1. And minus 0, so e to the power 0 is 1, and minus again e to the power minus 0 is 1, so I get e minus 1 by e. So yeah, I mean this can be written like e square minus 1 by e. So the correct option here is A. Now this is question number 29, and the only purpose for me writing all this question number is that I want you to answer in comment section, because if you have watched the video and you have understood the things, you should be able to answer this, because it similar kind of problem I have done. This is also something, question number 30, so you have to answer it in comment section. So how you have to answer? You have to answer question number 29 option C or B or whatever is the option, and question number 30 and the option is this. Okay, so both these two questions I am leaving for you so that you should be able to answer. Now let us quickly talk about this one, and this is a good question. So I would expect you, because you have watched the video till the very end, so I would expect you to be able to solve this question. So answer this also in comment. Answer in comment. And what is this question number? This is question number 31. So 3 questions I have given you to answer in the comment section. Comment. Next question. The Fourier coefficient b1 in the Fourier series expansion of f of x is equal to x. So f of x is equal to x is an odd function. F of x is equal to x is an odd function. So if I have to write bn, bn will be written as 1 by c. The length of the interval here is 2c is equal to 2 pi. So the length of the interval c is equal to pi. So bn is 1 by pi, or rather, since it is an odd function, so I can write bn as directly 2 by pi. Okay, and a limit is 0 to pi, and x and sine nx dx. Okay, got it or not? I hope it is clear. So you just have to integrate. So how will you and one more thing, it is actually bn, and I want to find b1. So let us take b1 directly. You write 2 by pi 0 to pi and x sine x dx. So 2 by pi integration x integration of sine x is minus cos x, and then minus minus plus cos x integration will be sine x. dy dx of x will be 1, so that I remember 0 to pi. If I put pi and 0, this term will go to 0. Sine pi 0, sine 0 0. And if I put pi and 0 here, I will get 2 by pi and minus pi cos pi, and if I put 0 here, it will become 0. So this pi and this pi cancel. Cos, so minus 2, and cos pi is also minus 1, so I will get 2. So the correct option is C here. So how much time is there in the video? Around 56 minutes, and this was question number 31, 32. So out of these 3 questions I have left for you, so approximately 2 minutes time I have taken to kind of solve each of the question. But if you want me to give you some kind of idea that how you should approach the Fourier series topic, you should be very clear about the Fourier expansion, the general result, what is even function, what is odd function, what is periodicity of a function, right? When the function is odd, how to write the Fourier series expansion, especially in the interval minus c to c. When the function is even, how to write the Fourier series expansion. So this kind of questions are usually asked. Just let me know, watch the video completely, and if you have watched and liked, share with all your friends, and do like the video also. And most important thing is that let me know through the comment section that what are the options of the 3 questions that I have left for you. And I hope you have noted it down, the question number 31, question number 30, and question number 29. Okay, so that's all from my side in this video. Thanks for watching, and have a very great day.